Hi there, I'm Kelly, and this is Application Security at Scale. So I'm a software engineer at Twitter. I've been here for about 5 years, and I've been on the application security team for about 1.5 of those. We are a small team in a large company. There's not that many of us compared to thousands of Twitter engineers. And our main focuses are static analysis and API and web security within the overarching realm of product security. Our customers are mostly developers, but we also care about the users too. And this is what I'm going to talk to you about today. So I'm going to tell you a little bit about what we've been doing recently and give you a little bit of background so that it makes sense why we're doing those things. So this is the reason why we are the way we are. We can't do security in a vacuum. We can't just partner with other InfoSec teams if we want to secure the whole application layer. We got to work across the whole stack. So we partner with people all across Twitter, especially API and web teams, to make the paved and easy path secure by default. Okay, so for a little background, some of you have most likely seen some version of this before, but I'd like to explain what it is if you haven't. In Agile and application security, we've got this idea of the software development lifecycle, the SDLC. Ideally, we want touch points with engineering and product teams like at every phase of the SDLC so that we ensure that we're giving folks the help that they need to design, build, and ship secure products. This is by no means a new idea, but it's helpful for my team to figure out how and where within the lifecycle of a product we can provide additional value. We've had a pretty consistently good toehold in the design and planning stages of the software lifecycle through our involvement in technical design reviews as security reviewers. We've also had static analysis as a first-class product for a long time. We have internal folks thinking offensively about our applications, and we run security training on various topics like how to threat model your service. We also saw an opportunity to better support our engineers throughout a couple of phases of the SDLC, however, the deployment and development phases in particular. Dino is at Square. He's not at Twitter, to be clear, but the feeling in this tweet makes it seem like his team is another good example of another team doing great work in this space. As an engineering team, we're constantly looking for opportunities to provide solutions that are available by default in the tools and frameworks that our developers use. In moving to work in a more cross-team way and working more directly with our customers in the last few years, we've been learning more about what other teams go through on a daily basis and more about what they actually want and need. In general, Twitter engineers are pretty willing to listen and fix stuff when we bring them issues, which is amazing. But we're still a company with plenty of old code and documentation and design decisions that we have to overcome or just plain adapt to. In 2018 or so, after we were working on other areas of product security for several years, we discovered an opportunity to provide more assistance to teams in a few areas of the SDLC. We had some tooling from earlier iterations of the team that we hadn't paid that much attention to for a while. It was in production and it was helping, but we could do better. We could do more to improve it. We had some interesting scaling and adaptation challenges at this point as well. What we had in terms of tooling available to developers was built for 2015 or 2016 era Twitter, and we have grown a bunch in terms of users and requests, as well as in terms of just overall company size and number of engineers over the last 5 or so years. We have specific needs as a company due to the streaming nature of some of our products, the number of inbound requests we see when considered as a distributed system, and so forth. We're moving toward more partnership-based engagements in terms of security engineering, pen testing, and also building stuff. We want to strike a balance between high-touch custom tailoring and security solutions that are adapted for large chunks of Twitter engineering. We want to skew toward things that teams outside the InfoSec org do not need a lot of specific security knowledge to take advantage of. So this is a cool tractor. I found it on the internet late at night, and it was really cute, so I just kind of rolled with it. We have a little rust on the underside, just like this tractor probably does, and plenty of technical choices we have to live with because that bed's been made. Every other company that's been around for a little bit has the same deal. Like, this is not the newest tractor that you'll find. It is an early Lamborghini Trattori. So let's imagine it's been customized over time by its owner. Maybe they're like a grape grower and this tractor is just the right size to fit between rows of grapes. It's a little different from your modern John Deere or Kubota, even though they do similar jobs. As the AppSec team, we try to make choices that will lead to the strongest outcome for the next 2 to 4 years, given our existing constraints. For instance, we already have lots of the things that we could get from something like a commercial WAF, a web application firewall, running in production. So that's not something that we would necessarily consider adding. We have ways to set rules to shape traffic if we're being attacked or some users threaten the quality of the experience of other users. We have web security protections. We have API security protections. We have great engineers all across Twitter who work on every aspect of our products and services. But just like a physical space machine, maybe this tractor, if you stop working on code, it's not going to look so shiny anymore. Like, it can seize up. The next person to work on this tractor might not have context about why some things are the way they are. It might not be the best fit for current circumstances. We might need to, replace some parts. Through maintenance, addition of custom parts, and adaptation, this cute little tractor might be difficult to replace with a brand new tractor, even if we might like to, since it's developed some quirks over time and, doesn't have all the fancy extras that you would get with a new tractor, like computers. For those of you who are considering tractors, I would highly encourage you to see what can be reused, what should be totally replaced, and what features are best suited for your own use cases and the existing constraints within your systems before you make a change to your current approach. But also, I guess, don't be afraid to buy a new tractor if it's the best option once you've considered the facts. We want our users to be confident in trusting us to keep their data safe, and we want them to have a good experience with our products and our platform. As application security, we want our work to be pretty much invisible to the Twitter end user. All right, so this is the part where I talk about our recent work. So we kind of wanted to keep the scope small at first. Though, for instance, open sourcing our code or including it in upstream open source frameworks might be an eventual goal, it seemed much more sensible to worry about later after we had adapted or adopted what we could to meet the current needs we identified within Twitter. We're also domain experts. We know application security, and it's our job to provide that knowledge to help the company. So anything we build should be suitable to help our engineers secure themselves in the general case. Like, if folks do have specific problems and want to write custom config, we should enable them to through providing that functionality and also giving advice on an as-needed basis. But that shouldn't be the thing that everyone has to do by default to be protected. We want to make sure that whatever developers actually get by default should be reasonably safe for our environment as well as tailored to their needs. But we also can't be too high touch. There are only a few of us, and there are way more Twitter developers than there are of us. Manual code reviews all across Twitter would be next to impossible for a team of our size versus everyone. But we also want to make sure that we build toward opt-out versus opt-in so things are easiest. We wanted to go for the low-hanging fruit where possible and build from okay to good versus okay to awesome to start with. We can iterate and we can get from good to awesome down the road. It was also important to us to document as much as possible. We've recently been leveraging Twitter's technical design document framework, where we would normally just have input as security reviewers helping out other teams, to bring in stakeholders from product teams and get their opinions as early as possible in our own design process. This has helped us to better collaborate with engineers all across Twitter and communicate our ideas for improvements through a medium that they're relatively used to. Okay. We also wanted to be able to keep ourselves accountable and be better accountable to leadership. We want to be able to reference metrics like who's opted out and shouldn't be, who needs more protection, who's actually adequately protected. We want to be able to periodically evaluate the effectiveness of our approach so that we can change things up when we need to. So the first example I'm going to give you is a library that we have been working on for Csurf protections. Before this, we had a whole variety of Csurf implementations. So we've been working on this stuff in relatively close collaboration with our customers because we want to more proactively meet their needs in the implementation and deployment phases of the SDLC. Csurf happens when an attacker is able to abuse a user's browser while the user has a live session to a website through some kind of scenario like an HTML phishing email. So in the background, what the attacker will do is they'll have like a post request or something which will execute and force the user's browser to just send the cookies for that live session that they already have. So the attacker doesn't need to steal credentials or anything like that. Like, it's much lower touch from their perspective. But, still dangerous for us. And most of the time, the protections we had were opt-in. Initially, we had tried to bake our Csurf protections into common code, which is used across a lot of individual backend Scala apps, which was a good start. But the way that we did this initially with Finatra filters, as I'll demonstrate in the next couple of slides, made it difficult for us to go back and actually audit what running in prod is actually protected or understand how good we're doing at a systems level. Much of our Csurf code was previously implemented as filters, which could optionally be added into your service when you build with Twitter's most commonly used service framework, Finatra, in Scala. So this is an example of what a filter might look like. This is not actually a Csurf filter because to show you all of our code would take longer than we have. But I just wanted to give you like a small example. So these are kind of like micro libraries. Code that is added to a service in a filter gets executed before the business logic and the controller the filter is applied to. You can compose filters and you can inherit from other filters, just like we have here with this extends simple filters line. So I just wanted to show you a simple filter so that you could get the idea. On the request path, this piece of code actually does nothing, but on the response path, it turns bubbled up exceptions from the rest of the app into HTTP error responses using functionality from the passed in parameter exception manager. Did it again. Okay. So this is where we're using exception mapping filters. So like what you would actually see in your code would be common filters. That would be the thing that you would include in your server. This is a good example of something that you might see across a lot of different services. So what we have here is many filters that are joined together in order. So A through E all get applied to the inbound request in order, then to the outbound response in reverse. Like, this is really cool and useful from the standpoint of code reuse, but it also means that just looking at service code, someone like me without context might see common filters added to that service and not know that it also includes exception mapping filter implicitly. So it's possible to chain your filters infinitely deep. It's quite possible to accidentally include duplicates, and there's no great way to get specific metrics on who does or doesn't have what beyond just the basic, like, okay, you have these packages. So this, like, at the filter level of individual services is a great example of a place to bake in security by default if you don't have that many customers yet. So if you wanted to share code between like 5 services or something, maybe for purposes of like unifying logging, like this is a really great way to do that. But it's, if we start sharing code across a lot of services, it's hard to audit and understand when reading due to the infinite chaining thing, and it doesn't scale super well. We really need auditability here, and we need a more central way to apply our code so that we have an easier time getting metrics and logs, and if something goes wrong, we're in charge of the implementation and carrying the pager for it, and it's not on each individual team to figure out what's up with our code. So this is how you would add this filter, this common filters into a backend Scala service. Just small example again. So these are applied in the defined order, these filters here, to this router object, which takes inbound requests. Our filters are, again, executed before the business logic in this my controller for the route the request goes to. Our request goes down the filter chain, response comes back up. Just kind of wanted to complete the example. After all this, you might be thinking, like, okay, big deal. Like, they can probably just use build tooling and this is pretty easy to figure out. But the thing is, historically, that's not what we have to deal with. We have like an entire package of security things that get added everywhere. So that doesn't tell us individually what's going on. So that's, that bed's kind of been made. Most filters are implemented as part of a larger package. Tracking package usage also doesn't tell you much about what's actually running in the service, since you can have package dependencies you don't actually use. If you wanted as a developer to be sure your own service is configured correctly, that is of course possible, but the real problem was once we got over a certain number of Finatra apps using our code, it just became less and less possible to understand what was going on. Like, there's no easy global way to say these 432 services have a class and these 23 don't. And this also doesn't protect people in a polyglot way. Twitter likes Scala an awful lot, but it's not the only language we run. We also have Node, we also have Go. Like, this does not protect services like that aren't running on the JVM. So repeating this, since it's a bit easier to visualize some of these now that you've seen an example. So we had limitations imposed by the way we were doing things, particularly with regard to scaling up and auditing. A filter is just one line of code in a service, essentially, and it's easy to miss. It is also hard to tell what's buried deep in a service's filter chain across all services built using the Finatra framework at Twitter. So filters are great for code reuse, not so much for security stuff that we would like to audit. If you're trying to protect entire systems or do anything at a systems level versus at the level of thinking about effects on a single service, it's not super efficient to bake repeated code into each and every service as well, especially if, like, in the case of Csurf, you generally want it active except for very specific cases where you want people to be able to opt out. So what we did, we merged a bunch of our Csurf implementations, there were many, into a single library. We dried up a bunch of the stuff that was, similar and just, repeated with one name or something. And we worked this new library into the routing system that sits in front of most Twitter services in an opt-out way where opt-outs can be done for specific API routes. The main reason we were able to get AppSec code into this internal routing system, though, which is where we ended up putting it to centralize it better, was through collaborating with the engineers who own that system. And we really lucked out because they were open to the idea of adding custom security code there, which not everyone might be. If we hadn't asked their opinion on the best way to protect a bunch of services at once in a way that is less language specific, we might have ended up doing something less effective. The key thing here was to get the right folks involved at the right point in our own design phase. Our main goal was to, with condensing all these implementations and trying to get them into a single place, was to scale up drastically in an auditable way all at once. Now, if you're a service owner, you can opt a specific API route out of any Csurf check if you end up needing to due to some business constraints without having to change any of your business logic or anything in your actual service. You just change your routing configuration, so that's pretty cool. Instead of protecting single client server sets at a time in a really ad hoc way like we were before, we want to protect as much of Twitter at once as we can in an auditable way. This is good for our customer-facing team since they don't need to know the details of our implementation, and it's good for us because it's auditable in configuration versus directly in code. It can also be hot-loaded, which is kind of nice, whereas previously you would have to recompile and redeploy if you had a problem. So the second example I want to give you is our content security policy tooling. So we've been working on making it easier for Twitter engineering teams to create and serve content security policies for their API endpoints. To give a brief definition, an API will serve a content security policy header with every response to the client in order to protect the front end from various types of attacks like cross-site scripting. So the browser knows what it can and can't execute. We provide our customers with a library for CSP configuration and a filter that they can apply that configuration on a service-by-service basis. What we don't want to see is this. This kind of huge policy is, if at all possible, better to avoid. We can't, this is hard to audit. It's hard to read. It's hard to know what in there you don't actually need or even maybe still own. This is a great example of why non-sing combined with strict dynamic is so powerful. This style of policy with these giant allow lists is hard to understand for everyone, and we want to simplify things. Not everyone at Twitter has adopted our updates yet. We're still working on rolling out to early adopters this quarter, and we'll roll out to more teams and services across the coming year. But this is where we're going. So we had support before in production for a limited subset of CSP v2, which is an older version of the CSP standard, and Safari still doesn't support CSP v3, so we're going to have to continue to support v2, but we have nonces at least, so we don't have to go full on allow list madness like that. But what we didn't have was we didn't have support for every directive in even the v2 standard, and we didn't really encourage the use of nonces over allow lists, even though it is so much more simple to set strict dynamic nonce everything and just allow that blessedness to carry through to everything that all of your sources include. We also want to reduce the number of config reviews that the AppSec team does for a team, literally just adding another Twitter internal domain to their staging CSP. We want to make it easier for developers to be confident in their own CSP changes and give them the tooling to test stuff. So this was another place where we looked for a lot of customer input, which helped us understand what we needed to provide, which was better documentation and tooling, right? So the need was people were kind of well, I have a CSP update, but what's it going to do? Who knows? So we wanted to help developers test their CSP before sending them to production in order to reduce the high-touch nature of reviews for uses of our CSP configuration library. We were also luckily able to get some insight from partner teams in InfoSec who work on areas like certificate management and benefit from their expertise. They suggested making our configuration dynamically updatable so that folks could hotload with Csurf routing stuff instead of compiled in. So this was also luckily a big win for helping us to write tooling to help developers write their own content security policies and test their updates. One thing we didn't want to do, though, was over-index on building all this cool custom stuff. We started with documenting good open source tools that devs mostly were not aware of, and then we built on what we couldn't find and still felt we had need for. April King, who recently joined us, brought Mozilla Laboratory with her, and she's been helping us to document use of that for our teams as well, so that's pretty darn cool. You may also notice a difference between the Csurf and the CSP projects, in terms of scoping the work that we started with and the overall impact of our initial effort. One of the things that we learned with the Csurf project was that going from an okay solution that worked for some apps to an awesome solution that works for all apps turned out to be more work than it made sense to do up front. Twitter is a polyglot environment, and it is important that as AppSec, we do our best to support the Twitter application layer, not just the part of it that's Scala. But with the CSP project, we found that it was better to go from okay to good instead upfront and build a foundation which we could iterate on in the future to get all the way to awesome. We started with just changing up our existing libraries and building tooling around using those libraries so our customers would be more successful at protecting their endpoints. And we will, in the future, build on that foundation to unify how CSPs are configured across Twitter. So the Csurf project took longer than I would have liked because we had to go back and make some changes to our existing OK state code and use in individual Scala services to get it to a better state after we fully set ourselves up to provide awesome cross-site request forgery protections for all of the endpoints, not just those served by Scala apps. I'd like to end with this quote from the Google Building Secure and Reliable Systems book. This is where we're ultimately aiming for with this paved path library and tooling work we're doing. We want our customers, the users, to mostly not need to keep headspace for us. We want our customers to know where to turn to when they have specific needs, but we want the general case to be taken care of by default. Thank you very much.